Hello everybody, welcome to the Unit 5 Robotics. Robotics, AI in robotics, it's the trend for the day. So artificial intelligence we have already seen in our previous videos. Here we are going to discuss about robotics. So we have robotics fundamentals. Okay, what do you mean by robot? Robot is a device which will do the task that is assigned by human. And the study of this robots is called as robotics. So robotics is the subdomain of engineering. It comes under engineering and sciences, and it includes mechanical engineering, electrical engineering, computer science, and others branches also. But these are the three main branches which are seen in robotics. Okay, robotics is based on all these three branches. The word robot was coined by Zay novelist. Okay, there was a very famous Zay novelist. His name is Karel Capek. In 1920, he had given one hit play. Name of the play is Rossum's Universal Robots. So over there, he had given the first time this name robot was seen in his play, and hence the name robot has come. Robot has come from a word robota in Zay. Okay, it is a Zay word which means a worker or a servant, or I can call it as a forced labor. Okay, a person is asked to be a forced labor. That is nothing but robota, drudgery. So from these words, the word robota arises, and from that word, robot has come into the picture. Robot. What is a robot? It's an electromechanical device. Means it is using the parts of electronics, electrical engineering, and mechanical engineering. So it is an electromechanical device that is reprogrammable. You can program it again and again. That means when I say reprogrammable, that means it is based on software also. Computer science has come into picture. Multifunctional. It can perform multiple functions and sensible for environment. So in simple terms, I can tell that robot is a machine which is assigned to do a particular task. Okay, robot is a mechanical device that perform human task either automatically or by remote control. You can automatically train a robot. It can learn from the things, or it can work remote control with human intervention. Okay, with or without human intervention, this robot can work. Fine. So here you can see robot acts as a manipulator. So the machines what you can see on the screen are robots that acts as manipulators. You can also have legged robot. Now when I talk about manipulators, that is a stationary robot. Okay, that robot is present at one place. It is used in industries to help production and all, right? Second one, you have legged robot. Legged robot means the robot is having legs so that it can move from one place to the other. It can also have wheels as shown in the next figure. Wheels are there with the robot. So robot can be without legs, it can be with legs, again it can be with wheels. So I call those robots as locomotory robots or mobile robots. Autonomous robots, we can have autonomous underwater vehicle. I'm just showing you the examples. What does these terms actually means we'll be seeing further. So it is underwater vehicle robot is also there. So this first one is under the water and second one is in air, that I called as aerial vehicle. Now why it is unmanned aerial vehicle? Because there's no man present over there with robot. Okay, man will be there off site controlling that robot, maybe with the help of remote, or it will be autonomous. Okay, autonomous means it can take its own decisions. So what can robots do is our question. Okay, so why does robotic has come into picture? Jobs that are dangerous for human beings. Okay, like for example, there is some nuclear power plant site is there. Fine. So over there is a job like cleaning the main circulating pump housing in nuclear power plant. So going to nuclear power plant is dangerous for human beings. So this job can be done with the help of a robot. Then repetitive tasks that are boring, stressful, labor intensive for humans. There are few tasks which are repeatedly we want to do it, right? Rather than having manpower for these kind of tasks which are boring, stressful, or labor intensive. Okay, where a lot of labor is required. Instead of that, we can have a robot for it. For example, welding robot is there. Manual tasks that human don't want to do. So you can see in the screen this task human is not interested in doing. So for such kind of jobs again we can design. Robots are designed. Okay, so it is scrub made robot. So this definition for robots, as we've seen different uses of robots, right, applications of robots, this is the definition of robot which is given. A robot is which is given by Robotic Institute of America. Okay, a robot is reprogrammable, as we've already seen. It is reprogrammable, it is multifunctional, you can reprogram it. Okay, so suppose it is doing one program, you can reprogram it for some other task. So it is reprogrammable. Secondly, it is multifunctional manipulator, which is designed to move material, parts, tools, or specialized devices through variable programmed motions for performance of variety of tasks. So it looks like little complicated, but if you divide it into parts, it's very simple definition. Like, it is reprogrammable, multifunctional manipulator. Okay, what it can do is it can move. What things it can move? It can move material, that is raw material, you can say, end products, you can say. It is used for moving those materials. Parts it can move. It can move tools also. Okay, or any other devices. So in short, it is used to move. So it is used to move various things in industries through. Now, in order to move, I require to program this robot. Okay, so it can move through variable program motions for performance of variety of tasks. So if robot is doing this, we get performances also. Okay, so talking about robotics, as I said, robotics is nothing but it is the study. Okay, it is the study and application of robotic technology, robot technology. Robotic is multidisciplinary field. Okay, multiple disciplines are covered in this. So you have study of mechanical engineering. Part of mechanical engineering is required, electrical engineering, and part is depending upon computer science engineering. So without any of these three, robotics is not possible. Okay, so it is multidisciplinary disciplinary field. So if I talk about mechanical engineering, it is concerned about so it is with respect to manipulator or mobile robot design. Mobile robot manipulator means what? Robot at a single place. Manipulate the mobile robot means what? Which can move from one place to the other with the help of legs or with the help of wheels. So in order to design these type of robots, in order to have kinematics, dynamics, okay, we require mechanical engineering. Then we require electrical engineering. It will give the flavor of robot actuation, electronic interfacing, because we require programming. That's why we require computer science, right? Programming, planning, intelligent part, artificial intelligence, this is all covered under computer science. Now, if I want my robot to deal with computers, right? To deal with computers, with sensors, with algorithms, I require electrical engineering, which will give me an interface between robot and between computer science, computers, right? So I require electrical engineering also. So you can see further, I can say that robotics deals with design, construction, operation, use of robots, computer science for the computer system for their control. Then again, I require feedback also. So sensory feedback, information processing. So this is all where I require what I call it as robotics. Okay, you can see Isaac Asimov, right? So this person had given three laws. Okay, we'll talk about laws. Like, you must have seen in movies, like robots. A robot can be an end danger for society, for human beings. Is it really? So it should not happen. We won't talk about is it really or what. Like, they are thinking that this can be the part of future if more machines comes into the picture. But this scientist Isaac Asimov had given few laws through which this robot should not disturb the society. It should be helpful to society, not a destruction to the society. So these are the three laws. A robot may not injure a human being. Okay, so robot should not injure a human being. So this is the first point. And or through any inaction allow a human being to come to harm. Okay, so through its action also it should not come. It should not harm human being. So the first point is human being should not be harmed directly by robot, or through any of its action also human being should not be harmed. Secondly, a robot must obey the orders given by its human beings. Okay, so it should obey the orders given by human beings, but it should, while obeying the orders, it should pay attention that such orders should not conflict with first law. Like again, if it's a human being's order that go and harm that particular the other human being, again this is not allowed for the robot. Okay, so it should obey human being law, but first law should not be disrupted. Thirdly, A robot must protect its own existence as long as protection does not conflict with first and second law. So it should also protect its own existence. So what are the three laws? First one, it should not harm any human being directly or indirectly. Second one is it should obey the order of all the human beings such that first law is not harmed. And thirdly, it should also protect its own existence, maintaining first and second law. Okay, these are the three laws which were given by Asimov. Okay, so the three laws are given like in pictorial format, like robot should not injure any human being, it should save human beings directly or indirectly. Third thing, secondly, it should obey the orders given by the human being, and thirdly, it should protect itself. And all the three laws should be maintained. And this society has also, people have also derived one more law which I call it as law zero. Okay, which are derived from these laws. So what is law zero? A robot may not injure humanity. So we are talking about human being in first law. So law zero says that it should not harm entire humanity. Through interaction, allow humanity to come to harm. So it should not allow, it should not at all harm humanity. Okay. So these are the laws that have to be taken in consideration by robotics. Okay, by this industry. So, talking about a brief about history of robotics, you can see in the picture, this is the first industrial robot. I talk about industrial robot. It is called as Unimate. It was the first programmable. It is the first programmable robot that is designed by George Deville, who coins the term universal automation. So, this person George Deville, he has given the term universal automation. He later shortens this term to Unimation, and Unimation is the, it became the robot company. I can call it as the first robot company. In 1962 it was framed. So you can see in the diagram Unimate, this is the first industrial robot. Okay, so again the features of Unimate, you can see it was the first industrial robot. It used to transport die casting, welding parts, drum memory. So these were the features of it. Then Wabot 1 came, right? This is the first humanoid robot. Okay, we'll talk about humanoid robot. The humanoid robot behaves like human being. They're trying to design robot that looks like or behaves like human being, with legs, with hands, these kind. Okay, those are humanoid robot. Wabot 1 was the first humanoid robot. Okay, so they tried to embed machine intelligence in it. Okay, vision system was there, motor and vision system. It was having ability to communicate. Scara. What about Scara? You can see it is having joint two link arm. Z axis is there. Okay, X and Y axis are pliable. So these all robots were used in industry to perform various tasks. 1978, this was very remarkable. Puma had come. Puma is robot arm. Okay, so it is called as programmable universal manipulation arm. Okay, or it is also called as programmable universal machine for assembly. You can call any, its short form is Puma. In short, it is arm, robotic arm. Okay, so this was developed by General Motors with the help of Unimation. Previously, we had seen robotic company, first robotic company Unimation. It, with the help of General Motors, have designed this robotic arm, which is very well used in industry. Okay, so it is Puma. Wabot 2. Okay, you can see Wabot 2. Inbuilt arm motors are there. Okay, so elimination of long transmission, successful interaction with human beings. Then, like present day human like robot, the first robot was produced which is similar in 1986. So this is you can see changes are taken place. EBO was designed, right? EBO. So it is called as artificial intelligence bot. Is called as EBO. It is having 64-bit RISC processor. You can see 8 MB RAM, sensors, actuators. So actually, we will study in our next video sensors and actuators, which are the very important part for manufacturing a robot. Okay, assembling a robot. So sensors and actuators. So it was there in ABO. So this is artificial intelligent dog which has been designed. So next, Asimo was produced in 2007. Asimo is very remarkable robot. Okay, so here there are few like it is humanoid robot, as you can see. Okay, so Asimo was humanoid. Sorry, we should not say was, it is. Asimo is a humanoid robot. It was created by Honda in 2007. It was manufactured in Japan. Okay, so you can see it is human like robot. What all things it can do is it is reading paper, right? So here are few features which are listed for Asimo, like it can hear, sing, speak, climb stairs, come down from stairs also, ascend as well as descend stairs, shake hands, play football, dance. Then it can manage a choir, it can teach a classroom also, it can recognize faces and voice. Like you can say that it is having all artificial intelligence embedded with it, right? Machine learning is there. You can also see the cost of a CMO, okay, and annual rental charges are also displayed on the screen. Then Robonaut 2 was there, right? Robonaut 2, it is having 38 power PC processors, wider range of sensing is there, okay? It works in microgravity, okay? Then Sophia, you must have heard about Sophia, right? So it is a humanoid robot which is given in 2015. So you can see these are very few features I've listed. Like it is having artificial intelligence. It can do facial recognition. It can do voice recognition. It can do speech to text technology is there with it, right? Visual data processing is there. Cloud network, blockchain technology. So all these things are embedded or used in order to design this humanoid robot Sophia. Okay, so you have understood like what all can be the applications of robot or what robots have been designed. So here we have types of robots. Okay, mobile robots. Mobile robots are the robots which can move from one place to the other place. Okay, either they can have legs to do this, so I call them as walking robots. Okay, or they can have rollers to do this, so it is called as rolling robots. Then comes stationary robots. Stationary robots are the robots which don't move from one place to the other. Okay, for example, Puma, it is a robotic arm. It is deployed at a fixed place in an industry. Okay, autonomous robot means the robot which is having intellectual. It can take its own decisions. That is autonomous robot. Remote control robot means human being is controlling that particular robot. So these are basically few types of robots. Okay. So talking about this mobile robots, we have polar robots. Okay. In polar robots are the robots which are found in the region where you have lot of ice, snowy region, right? Snowfall is there, right? Over there you have polar robots. Aerial robots are the one which can fly in air, right? They operate in air. Underwater robots are there, as I shown in very starting part of the video. I'd shown the diagram. The robot is there in the water. Delivery and transportation robots are there. These are all mobile robots because they can move from one place to the other. Okay, so they are having unmanned ground vehicles are there. Okay, you can see in the diagram that is a vehicle that, okay, it can move from one place to the other. It is having wheels. So these kind of robots are having legs, tracks, wheels. Okay, these robots are autonomous. These robots can be autonomous or non-autonomous. Now what I can call it autonomous. Autonomous means they are able to move and explore their surrounding without any external direction, without any sort of external direction. They don't need human guidance, or you can say they need very little human guidance. Okay, those are called as autonomous. They can take their own decisions. Okay, how human beings have designed them as such. Guided, non-autonomous. The other one I call it as non-autonomous, which is also called as guided. They need some form of instruction or guidance. Okay, they need more guidance as compared to autonomous in order to move from one place to the other. Okay, so you can say that in transport, payload, revenue producing cargo, ocean, space exploration, navigation, assist doctors in surgery, all these places we need robots. Okay, so mobile robots, you can say all these polar robots, aerial robots, these are the example of mobile robots. Now if I talk about rolling or walking robots, the robots that can roll or they can walk, they are all mobile, right? Rolling robots have wheels to move around. Rolling robots can be used on any flat surface, right? Walking robots, rolling robots are having wheels, right? So, in order to wheels to operate, they require flat surface, but a rocky terrain won't do. When I talk about walking robot, they should have legs, as shown in the figure. There is a walking robot. Okay, so now this walking robot can move on rocking terrain also because they have more than two legs. You can see in the picture it is having 6 legs. So they can have 6 or even more legs than that in order to balance itself in rocky terrain. Okay, so over there, rolling robots won't work in walking terrain. That's why walking ones are there. Stationary robots are there. Now, stationary robots, as I said, they are fixed at a particular location, right? So they are used in industries. Fine. So they are fixed in one position. They can work for day and night. Robots, of course, they can work in day and night, and they can be reprogrammed also. That is very good part of it. They have arms. You can see those are the parts of it, right? So this is robotic arm, where its part is waist, shoulder, elbow, and wrist. So this is robotic arm. Okay, as I've already said, it is used in industry. You can see autonomous robot over here. This robot is playing football. Okay, so see, that means autonomous means what? They have their own brain, right? Machine learning is there. Artificial intelligence is embedded in them. So using machine learning, using artificial intelligence, using natural language processing, these all robots are designed. So they are self-supporting or self-contained robots. Okay, they are called as auto robots. They can perform tasks with higher behavior of autonomy. Okay, so they can take their own decisions. They have the ability to walk, right? They can perceive the environment, they can make decisions, they can actuate a movement. So they have actuators. Now what is actuators, we will be learning in our next video. Okay, so these are the autonomous robots. They can actually software is there which can make them run. Then the next example is remote control robot. Okay, so over here, the previous one was autonomous robot. Human control robot, I can call it as non-autonomous because it requires human guidance. So human guide them using a remote control. Now there are the places where human being cannot go. You can see over there, right, in the picture. Now for example, in order to detonate a bomb, it is safer to send a robot rather than human beings. So at that time, remote control robot comes into the picture. Dante 2. You can see in the picture, it's Dante 2. It's a NASA robot that was designed to explore volcanoes via remote control. So these are the robots which human is going to control using a remote control, right? You can see here you have telerobots. Telerobots are the robots which are far away from human beings. So those kind of robots are called as telerobots. These are used to perform the jobs in the places that are too far from human reach. Okay, they work deep below the sea and in space. Of course, these robots are, can be mobile or can be stationary, depends. But telerobot means they are far away from our reach. Okay, we will go and deploy them like that. Military robots, they are the remote control mobile robots which are designed for military operations, right? They are fitted in camera and are sent to enemy territory to capture the images and send those to the operator. So these are very important robots. Okay, so these are military robots. Space robots. So these space robots are called as rovers. Okay, we here like rovers have been sent. So rovers are nothing but robots. Okay, used in space. So these are used in space for exploration. They are fitted with scientific equipment to analyze soil samples. Okay, take the photos of the planets and other distant bodies. We hear na robots are nothing but space robots. You can see in the diagram a space robot. So robot for intelligent environment, like we have seen, like service robots are there. They can service robot means what? Robots to serve humanity. Actually all are serving humanity only. Security guard robot can act as a security guard. It can act as the delivery, then it can delivery machine. It can be used for cleaning, right? Moving assistance robots can be there. Like if you assign it certain work, it will do it for you. Okay, so these are all mobile robots. Okay, and even elderly people are there or disabled people are there. For them to have motion or mobility, robots help. Like you can see in the diagram, there's a machine at the end. Okay, to help disabled people. So that is intelligent environment. Robot is working in intelligent environment. You can see robot is helping in industry also, in that furnace. Robot system used for manufacturing, right? Industrial robots are automated, programmable. Okay, they're capable for movement along three or more axes also. So what job they can do in industry? So few robots can do welding, few for painting. Okay, different robots are defined for designed for different activities, assembly, disassembly. Okay, and to do repetitive task. Okay, repetitive task, robots are used in industry for material handling, for transporting material from one place to the other. Virtual robots. Okay, this is also very good. Virtual robots. Okay, now what are virtual robots? Virtual robots means robots you cannot see, but at the end robotics is there. For example, programs or building blocks of the software inside a computer. In your computer, these are the programs, okay, or building blocks of software. So it it is the simulation of a real robot. Okay, it performs a repetitive task. Best example is World Wide Web search, which is taking place in World Wide Web. So you must be knowing web crawler does this. So what is web crawler? It is intelligent program which has been written which will crawl web to find out what user needs. So web crawler is the best example of virtual robot. Okay, the job is being done by a machine program for you. So it is that robot, we call it as virtual robot. Okay, internet has countless robots crawling from one side to the other. So web crawler is an example of virtual robot. Chatbot, number of places we've heard about the chatterbot or chatbot, in short it is called as. So what is the chatbot? Machine is interacting with you, right? So this actually the program written. So those programs are nothing but chatbots, and chatbots are nothing but virtual robots. It's an application of robotics. Okay, so these robots simulate conversations with the users on internet. We feel like we have lame user feels like that he is communicating with a human being at the back end, but it's not human being, it's communicating with machine. So one of the first chatbot was Eliza. Okay, so we've talked a lot about robots, but there's just application like where they can be used. Okay, so collaborative robots, or which we can call it as cobots. Okay, so these are the industrial robots. These are cobots are nothing but industrial robots only. So they are working with human in production process. In production process, they are helping human beings. Okay, they are smaller, flexible, and easy to program. They're not going to replace human workers, but help them, supplement them. Okay, one example I would like to state here: this Paradigm Electronics in Canada, its productivity increased by 50% by using cobots. No single worker lost his job. Okay, so cobots are very helpful in industry. Secondly, we have industrial robots. Okay, cobots, and what is difference between cobots and industrial robots? The cobots are small, compact. Okay, smaller and flexible. Industrial robots are large. Okay, both are used in industry only. So industrial robots are nothing but programmable machines, right? It can be used to handle assemble workpiece in industrial environment. Fine. So you can see robotic arm, which we've seen previously, gripper. Okay, these are all industrial robots. So industrial robots are used in automotive industries. Then we have AGV. AGV stands for automated guided vehicle. Okay, driverless transport vehicle, which are guided without touch. Okay, either by remote control or completely they are autonomous. So there's no need of remote control also. Okay, so it is autonomous guided vehicle used to transport materials in production facilities from one place to the other. They are used to transport the materials. Next, we have service robots. Now, talking about service robots, we have domestic robots like the robots which can help you in lawn mowing, okay, vacuum cleaning, window cleaning, household chores. Like instead of maids, people can hire these robots. Okay, security, that is looking after your house. You're there in house or you're not there in house, it will look after your house. Hospitality is there. Okay, to serve food, beverages. Obviously, at many places, these robots are there in service. Okay, serves sorry, it is used to serve meal on a tray, right? Fetch new snack. Agriculture also, it is used in agriculture. Okay, like drones are there which are used for monitoring. Robot arms are there, and cameras are installed on harvesters. Okay, so many places these are there. Then medicines, in medicinal field it is used to assist a doctor for its surgery. So all these are the service robots what we are talking about. Toy robots are there, which are there. Abo is a toy robot, right? That is a robotic dog. Roberta is a toy robot, so it will help your kids also. It becomes friends for your kids, right? So these are all the service robots. Then talking about humanoid robot, they look like human beings, right? We have seen just the pictures of humanoid robot. Movements, their movements are inspired by human locomotor system. Josie Pepper is one more example of this humanoid robot. Josie Pepper, it is a robot to assist the passengers at Munich airport in Germany. Okay, it needs voice recognition, gesture recognition. Means it is having all these things which has built that robot Josie Pepper. Gesture recognition, voice recognition, facial expression analysis, artificial intelligence, machine learning, all these things have built that robot. So currently it is there at Munich airport, which is present at Germany, in order to assist the passengers. Okay, so safety and security also robots help us. So main parts of robots are there, which we will be covering in our next video. We are going to see in details, but here you can see a robot is made up of mainly of control systems, sensors, activators. This slide we will be covering in details in our next video. So here we have finished with introduction to robots and robotics. Okay, so in our next video we will learn about the parts or the architecture of robot. Thank you.